Hi students, in this first video for online lecture 9, we are now going to talk about the covalent compound nomenclature. So as we start to go looking through here, when we're dealing with our molecular compounds, this is going to be a nonmetal or in many cases, a nonmetal with nonmetals or a nonmetal with metalloids. One of the first things that you're going to need to do to separate when it comes to the nomenclature is determine what compound it is. If it is ionic, you're going to use the previous nomenclature you've seen in the previous lectures. If it is going to be molecular or covalent, then you are going to use the nomenclature that you see in this video. So we are allowed to use common names. Common names actually predate the systematic naming that was adopted by IUPAC. So common names that you see here are water instead of dihydrogen monoxide, or in the cases of ammonia. You also see one other when it comes to our methane. So you are allowed to use the non-systematic names if it is considered well within use and predates the naming system. However, if we are going to go systematically, we are going to take the element that is furthest to the left in a period, remember that is your horizontal row, and closest to the bottom of a group, so that means further down the periodic table, and we are going to place that first in the formula. Historically, we can also call that the most electropositive if you are thinking about it that way. Then, if more than one compound can be formed from the same elements. What we mean by that is in the case of our H2O, remember that this is going to be water, but we can also have hydrogen peroxide, so that's H2O2. If there are multiple possibilities for the same element mixture, then what we need to do is use the Greek prefixes in order for us to then indicate the number of each atoms that are in this molecular compound. If there is only one way of doing this, or only one type of mixture between the two elements, then we do not need the prefixes. However, the prefixes are mono for one, we have di for two, tri like tricycle for three, tetra is four. Then the nice thing is we go penta, hexa, hepta, octa. This is nona and deca, which are typically the Greek prefixes that you are going to see once you get to organic chemistry and start talking about carbon chain length. Finally, the last element gets the typical IDE ending. This is the only similarity that we are going to see between the ionic compounds and our molecular covalent compounds. So let's look at the example of the friendliest acid that we have. However, it's not an acid in this case. This is just the molecular compound. In this case, we are going to name this hydrogen iodide. Hydrogen, being further left in the period, gets to be placed first. Then iodine, being the second element, we are going to remove the INE ending and we add the IDE ending. So now we get to this compound. Notice that I have nitrogen with 3 chlorines. So this is going to be nitrogen trichloride. Notice that you do not put the mono on the first element if we do not need it. So in this case, we are not going to call this mononitrogen trichloride. We are only going to call this nitrogen trichloride. So then finally, we get to this example. Notice that we have a sulfur with 2 oxygens. So this is going to be sulfur dioxide. The reason we do this is that we can also have SO3, which would be sulfur trioxide. Now you can see that we are starting to get multiples of our first element. So notice that we are going to have to add in the prefix to both of our elements. That means that we are going to have dinitrogen, tetra, meaning 4, bromide. Also notice that the ending has changed on bromine to add in the IDE ending. So then I get to NO2. What would this be? Well, notice that we have nitrogen and we have 2 oxygens, so this would be nitrogen dioxide. Now you can see the importance of the prefix labeling because now I can have N2O. This is a compound that is going to have the same constituent atoms, but they're going to be in different ratios. This means that we have to use the prefix rules to separate them. So if I have two nitrogens, this is going to be called dinitrogen. Then I must use the monoxide. Historically, you're going to see the monoxide used in the second element. This can be done when we are using such things as carbon monoxide and the difference with carbon dioxide. These are two compounds you're incredibly familiar with. You know their names and have used it. You just have not used the rules behind them. So let's try these examples. Name the following molecular compounds. So notice for A that I have silicon and I have chlorine. So in some ways this is going to be silicon chloride, but I need to let you know how many chlorines I have. So now I have 4, so that means that I must use the tetra prefix. So this is going to be silicon. Now I need to tell you how many, so this is going to be our tetra. And then finally we add in our second element, which is chlorine, but I must add the IDE ending. So I have silicon tetrachloride. So let's look at B. Notice that I have 4 phosphorus and 10 oxygens. One of the things that you're going to see is typically what we call the vowel rule, and I will actually show that here in a moment. So we need to tell you how many phosphorus we have. So first off, we must start with our tetra prefix, and then I will have my phosphorus. And now when I get to my oxygen, we are going to have the 10 prefix. Normally this would be deca, but because the A and the O are both vowels and would conflict in sound, we are going to go and omit the A and immediately just go into dec oxide. Do not end up putting deca oxide or pronouncing it deca oxide because that is not systematically correct. For B, we have tetraphosphorus decoxide. For our second set of examples, write the chemical formula for the following molecular compounds. I have carbon disulfide. So carbon is going to be C, and di, meaning 2, means that I need to have 2 sulfurs. So this is going to be S2. For B, we have disilicon, so that means that I must go and have Si, and we have a 2, and then we get to hexabromide. Well, here is our prefix. Hexa, you might remember that from a hexagon, is going to have 6. So this means that I need to go and have Br6. So my formula is going to be Si2Br6. Let's try this example. This is an example from the fall of 2017. What is the chemical formula for the following name? Dinitrogen heptabromide. So let's look at the dinitrogen part first. The di prefix, meaning that there must be 2. So that would get rid of answers A and E. So now we need to go look at the hepta prefix. This is one that is typically made very, very difficult and is one that most people forget most often. 7 and 9 are the ones that people historically do not remember. 7 is hepta, 9 is nona. So in this case, we need to find 7 bromines. That is going to be answer D. So as we're working through here, you want to be able to systematically use the information that is provided to you in the name, or take the formula and be able to go and produce the name. So now let's look at this naming cheat sheet. We know that we have a compound, but immediately we must need to split the rules. So as you see with the ionic compounds, this is going to be your previous lectures. So that is going to be a cation, meow, which is a metal, or a polyatomic such as ammonia, and an ion. So these are going to be your charged species. So we need to be able to look at our charged compounds and see the charge difference. That was the previous lecture. So then as we go to our molecular compounds, Historically, these are going to be our covalent species. These are going to be the ones that contain our binary compounds of nonmetals, whether they are the same compound or they are different atoms going and forming. Once we get to our ionic compounds, remember that we had really two different naming sets. One in which we used the IDE ending for our second element, but it was really without the idea of the Roman numeral. So if we go down the left path, you'll see that the cation, meow, has only one charge. That means that it is always going to have that same charge. And you will see the list here of all of the metal ions that have only one charge. Then what happens is if you have the cations, meow, that have more than one charge, historically the transition metals and the lanthanides and actinides, this is when you use the Roman numerals. So the nice part in all of here is that in a lot of cases, even though that we have been systematically naming for most of this chapter, it can be broke down into three really distinct patterns. If it has only one charge, great, we don't need a Roman numeral, we use the ionic rules. If it has more than one charge possibility on the metal, then we use the Roman numerals. And then finally, with the covalent, we are going to use the Greek prefixes while naming. So as you're looking through your compounds, make sure that you are going and selecting the correct path and using the appropriate and correct rules. In the next video, you're actually going to see the hardest naming of compounds, and that is going to be our acids and our binary acids, historically coming from our polyatomic ions. Have a great day.